Hello, welcome back once again. Today we have another interesting definite integral from the MIT Integration B 2024, right? So we have this interesting integral with an infinite nested radical at the denominator. The integral from 0 to 6 of x divided by the square root of x plus square root of x plus square root of x plus and so on dx. So how exactly are we going to solve this problem? Let's call this integral first I, right? Now the first thing to do is to make a substitution. But the substitution we're going to make here is to let the whole of this nested infinite radical or infinite nested radical equals another variable. Let's call it t. So we're going to let t equals the square root of x plus the square root of x plus the square root of x plus and so on, right? Now, when you square both sides of this equation, so let's square both sides of this equation. Now, the left-hand side, we have just t squared. This is equal to, now, this is how this works. This square here gets cancelled with the big square root, and we're left with x plus the square root of x plus the square root of x plus the square root of x plus and so on, right? But did you realize something here? There's something really cool here, and I will let you guys know. I know some of you guys already say it. So here, this is our t. Don't forget that, right? So we have here t squared is equal to x plus t. Now, to solve for x here in terms of t, our x is equal to t squared minus t. But we need to solve for t, right? So let us solve for t. Now, to solve for t, we derive the following equation: t squared minus t minus x is equal to 0, which is a quadratic equation where we have our a is equal to 1, our b is equal to -1, and our c is equal to -x. Now we apply the quadratic formula. T is going to be equal to -b plus or minus the square root of b squared minus 4ac, and then divided by 2a. But take note of this. This infinite nested radical can never result to a value which is less than 0, right? For this reason, we're going to take the positive value, which is going to be -b plus square root of b squared minus 4ac, and then divided by 2a. Now, trying to make our necessary substitutions. So here, our t is equal to -b here is going to be 1, and then plus square root of b squared is -1 squared, which is 1, minus 4ac. 4ac is -4x, then minus 4x will give us positive 4x, and then divided by 2, right? Okay, cool. Now let us check our limits. We know that when x is approaching 0, our t is going to approach, if you plug in 0 inside this value of t for x, in terms of x, we're going to have square root of 1 plus 4 times 0, which is 0. 0 plus 1 is 1, so we're going to have 1 plus 1 divided by 2, which is 1. So when x is approaching 6, check it well. If you plug in 6 here for x, then you will find out that our t will approach 3. That is cool, right? Okay. Now for my original integral, which is equal to the integral from 0 to 6 of x divided by, sorry for this, so of x divided by the square root of x plus the square root of x plus and so on dx. In terms of t, this is going to be equal to the integral for, so our lower limit here is 1, running from 1 to 3. Then our x, don't forget our x is equal to t squared minus t divided by this nested infinite radical, which is t, and then multiply by our dx. Oh, we didn't find our dx. That is true. So from this value of x here, So if you differentiate both sides, we get the x is equal to, so this is going to be 2t minus 1, right? So our dx is equal to 2t minus 1. And then dt. So here our I is going to be equal to, that is the integral from 1 to 3. So, you know, t squared minus t divided by t squared divided by t will give us t, right? Minus t divided by t, that will give us 1. And here we have 2t minus 1, and then dt. So we're going to expand. So expanding, we get the integral from 1 to 3, right? Of, that's going to give us 2t squared minus 3t and then plus 1, and then dt, which is equal to, using this power rule, the integral of x raised to the power of n dx is equal to x raised to the power of n plus 1 divided by n plus 1, right? So this is going to be equal to here 2 multiplied by t cubed divided by 3, right? And then minus 3 multiplied by t squared divided by 2, and here plus 1 plus t, right? And our limit running from 1 to 3. Now let us carefully take our limit. So taking our upper limit first, we get 2 multiplied by 3 cubed divided by 3, that will give us 3 squared, which is 9. Then minus 3 multiplied by 3 squared is 9, and then divided by 2, and then plus 3. And we're subtracting, then taking the lower limits, we get 2 multiplied by 1 divided by 3, minus 3 multiplied by 1 squared is 1 divided by 2, and then plus 1. So here our I is equal to, this is 18, right? Minus, that will give us 27 over 2, and then plus 3. Then minus here, 2 over 3, minus 3 over 2, and then plus 1. Okay, so from here our I is equal to 18 plus 3 is 21, right? So we have here 21 minus 27 over 2, and then minus, so here 2 over 3 minus 3 all over 2. So what is that giving us? Sorry for that. So that is giving us negative, is that negative 2? We know 2 times 2 here is 4, 4 minus 9, so negative 5 all over 6, and then plus 1. So from here, our I is equal to, so 21 minus 27 over 2 is giving us 15 over 2, and then minus negative 5 by 6 plus 1 is giving us 1 over 6. So from here, we're going to have the following: 45 minus 1 divided by 6, which is equal to 44 divided by 6. Reducing 2, we get 22 over 3. So we have our solution, right? So we can say that the integral from 0 to 6 of x divided by the square root of x plus the square root of x plus, and so on, dx is equal to 22 over 3. And this right over here is our solution. If you really enjoyed the video, please kindly support the channel by subscribing. Also like, comment, and share.